Okay, so we're making an amplifier chain with a common base amplifier followed by a common collector amplifier to get an input impedance of 50 ohms and an output impedance of 50 ohms. So we're going to start with our common base amplifier. So this is our common base amplifier. This is going to be our input. This is going to be our output. We're trying to bias it, and so we calculated that we want an RE1 of 500 ohms and we wanted an RC of 500 ohms. And then we wanted these, we don't really care too much. We don't want them too big because we want to keep our input impedance small. So let's just pick them equal to a kilo ohm. We are going to sweep this one. So we're going to do a dot step param for R from 1K to 100K. Simulate, edit, DC operating point, and then we run this. And we are trying to get the current to be equal to 0.52 milliamps. So for 0.52, we need 10 kilo ohms. So we do 10 kilo ohms. And we check, we have 0.54 kilo ohms. The voltage here is about 9 volts. The voltage here is 0.2 volts, so we have enough headroom. If we wanted a little bit more, we could get this to be, this is fairly close to 10, but we're just going to say that's okay for now. Now we're going to do our next stage. So we are going to copy this stage. Over here. We no longer need a collector resistor. And we want this to be 19 kilo ohms. We're going to want these bigger. We want these to be a lot bigger than the 500 ohms because we don't want loading between these two. So let's start with, this is 500 ohms, so let's do 10 kilo ohms. And in this case, we want this to be at least 10 kilo ohms. And we run this. And we want this to be 5 volts. We only got up to 0.44, so we're going to change this to 10 kilo ohms. We're going to change this to our R. We're going to rerun it. And then we want 5 volts, so we move this down to 5 volts. And we want 13 kilo ohms. And you see we're at 5 volts, we're at 20. We're at 26 milliamps, so all that's good. So now we're going to take these two together and we are going to connect this output to this input. So the impedance seen by this capacitor is going to be 500 this direction plus something really big in that direction. So let's just say 10 kilo ohms. So this doesn't need to be too big, so we'll just put in a micro there. We're going to capacitively couple this one for our output. We're going to put in our input source here. And then we're going to connect that up. Now this one is going to see like 50 ohms this direction and 0 this, so this one has to be a lot bigger of a capacitor. So this one needs to be 1 divided by 2 times pi times, we want the 50 ohms, and we want it to be less than the 1 kilohertz, so let's put in like 100 hertz. So that's like 30 microfarads. Let's just put in 100 microfarads there. And then this is going to be our output over here. On our collector. So this is our, see, the base doesn't have an input or an output, so this is our common base amplifier. This is our common collector amplifier, and we are ready to run it. So we are going to switch this over to a transient. We are going to get rid of our step param, and we run this, and we see we have an input of the 2 millivolts. We can look at the output here. This is equal to 17 milliamps, and then we look at our output here, and we're at 17 milliamps. So we wanted a gain of 10, so we want 2 times 10, we want 20 milliamps, so we're not quite where we need to be. So we're going to increase this a little bit until we get up to the 20 milliamps. So we take So we're going to put in 550 ohms. Now we see we're at 19, 560 ohms. Let's check everything, make sure that we're good on that. Okay. So we go to 580. And we're at 20, so 575. 570. Okay, so we're looking pretty good. We're like 0.1 out of that. Okay, and then we check our current here. And our average current you see is 0.5 milliamps. We wanted 0.52. Oh, this is 5.4, so we're pretty good over there. And then we come over here, and this one is 0.26. We wanted this to be 0.52. Oh, I made a mistake. This was supposed to be 9K. So we're going to have to redo our DC bias point to get this one back to the 0.52. So we're going to go back to our DC operating point. Change this to R. And we're going from 10K to 300K. And again, we want to be at 0.52. Let's see, do we make it? .52, so we want 11 kilo ohms. So we run that and check our current, and you see we're at 0.51, so we're pretty close. So now we can go back and check everything. So we're going to delete this, switch over to a transient, and run this. And we are at 19.9 millivolts. Let's change this up just a little bit. and there's our 20. So we have 2 coming in, and we get 20 out, so that's a gain of 20. We want to check our headroom. So here we have a headroom from 9.6, so we have a headroom of about 0.3 volts up. Lots of headroom on the bottom, so we could play around with that if we wanted to. We're only putting 1 millivolt gain of 10, so everything is good, and we are done.